Example, given sine A is equals to negative 12 over 13 and it is in third quadrant. Find the other functions. So we will have the coordinates, and this is the first quadrant, second quadrant, third quadrant, and this is fourth quadrant. And sine A is equal to negative 12 over 13. For sine A, that's negative 12 over 13. And this is in third quadrant. So first, second, and this is the line. And this is the angle. And so, we form a triangle. And this is 90 degrees. And if this is angle A, therefore, this is the opposite side, this is the adjacent, and this is the hypotenuse. And for sine, that's so for SOHCAHTOA, and this is equivalent to O over H. And for the coordinates, upper side of the y-axis, so this is y and this is x-axis, these are always positive, and for the left side of the x-axis, that's negative, and for the lower part of y-axis, it is also negative side, and this is equal to 0. And if we notice, opposite side is negative sign, while adjacent it is also negative sign. We will identify first what is the value of O, or the opposite side, and the value of H. And H is always positive. Therefore, sine A is equals to negative 12 over 13. H is equal to positive 13. O is equal to negative 12. To find the value of A, using Pythagorean theorem, that's H squared minus O squared, and H is square root of 13 squared minus O, which is the value is negative 12, open close parenthesis, negative 12 squared, and this is equivalent to, so 13 times 13, that's 169, minus 12 times negative 12 times negative 12, the value is always positive. So negative 12 times negative 12, the value or the sign is positive. So 12 times 12, that's 144. And 169 minus 144, and that's square root of 25. And the square root of 25, A is equals to 5. Therefore, the adjacent side is 5, and that's negative. So therefore, this is negative 5, and this is negative 5. Using the other functions, find the other functions. First, sine A, just copy the value, that's negative 12 all over 13. Next, we have cosine A, and it is adjacent over hypotenuse. Therefore, A, which is, we find the value, that's negative 5 all over H, that's 13 here. And tangent A, that's opposite over adjacent, or O, that's negative 12 all over A, that's negative 5. And it is equivalent to negative over negative, that's positive, or 12 over 5. And this is for tangent A. While the reciprocal of sine A, that's cosecant A, and it is equivalent to H over O, or 13 all over negative 12. And the reciprocal of cosine A, that's secant A, and it is h over A, and h is 13 and A is negative 5. And the reciprocal of tangent A, that's cotangent A, and it is A over O, or negative 5 all over negative 12, and it is 5 over 12, and that's cotangent A. Therefore, the remaining values or the functions are cosine A, that's negative 5 over 13, tangent A, that's 12 over 5, positive, cosecant A, that's 13 over negative 12, secant A, that's 13 over negative 5, cotangent A, that's 5 all over 12, and it is positive. So these are the values or the remaining values for the given sine theta or sine A, that's negative 12 over 13, and it is located at third quadrant. So these are the solution.